Good morning and thank you for joining us today. We'll start the session in a minute or two. Let's start the session. Good morning and thank you for your patience. Welcome to the session Decoupling and Migrating Monolithic Application to Microservices on Cloud, hosted by Cloud.in. I'm Suvarna Jadhav, working with Cloud.in as a strategic partnership and alliance manager. For today's session, we have Ms. Rutuja as a speaker. Rutuja is working with Cloud.in as a cloud consultant. Decoupling and migrating a monolithic application to microservices on cloud is a strategic approach that offers numerous benefits, including increased scalability, flexibility, and agility. Rutuja will share some interesting insights on the same. All attendees are muted by default and cannot be unmuted during the session. If in case you have questions in between the session, please ask the question through the question section. I request Rutuja to start the session. Over to you.
Thank you so much, Suvarna ma'am. Hi, good morning, everyone. I welcome you all to this session. We will be understanding and learning a very basic idea of how you can start with decoupling and migrating your monolithic application to microservices on cloud. So firstly, let us understand what we have today as an agenda for the session. Firstly, we'll be looking what the difference or maybe understanding what is a monolithic architecture and what is microservices. Next, we'll understand when should we modernize from monolithic to microservices. Later, we'll look into the benefits of microservices and we'll understand a process of how you can decouple from your monolithic application to microservices. Also, we'll be looking into services that are offered by cloud computing, for example, AWS Cloud that offers services for your microservices. And we'll also look into some best practices that should be configured while using microservices. So firstly, let us understand what a monolithic and a microservice architecture is. So a monolithic architecture is a traditional software development model that uses one code base to perform multiple business functions. All of these software components in a monolithic system are interdependent due to the data exchange mechanisms within the system. And it's a very restrictive and time consuming to modify the monolithic architecture as small changes impact large areas of your code base. So basically, in a monolithic architecture, you have your services or your processes dependent upon each other. And this becomes very difficult in times when you want to modify your architecture, your application, or you have some code changes to be made. On the other hand, in contrast, when you look at microservices, this These are an architectural approach that composes software into small and independent components or services, as you can call them. Each of these services perform a single function and communicate with other services through a very well-defined interface. And because they run independently, you can update them, modify them, deploy them, and scale as you require. So there is no dependency as such in this architecture. So basically, microservices help you. There are many advantages of microservices, as we just discussed. Rather than wherein monolithic architecture, you are dependent upon all these services. So microservices help you innovate faster, wherein monolithic architecture limits an organization's ability to introduce new business capabilities and technologies in existing applications. Meanwhile, you can see that microservices are independent software components that developers can build and with different frameworks and software technologies as per their use cases. The loosely coupled services between microservices allow the businesses to innovate certain components more quickly with the innovations that are coming in market. This also reduces the risk. So both in monolithic and microservice applications experience code conflicts. You experience bugs and unsuccessful updates. However, in a monolithic application, if you consider, it carries a more significant risk, like when developers release new updates as the entire application presents a single point of failure. A minor error in the code base can cause the whole application to fail. So if by any chance you have a code update and there's some error in the code, the updated code, then the whole application can fall because you have all the services, all the processes in a monolithic application interconnected to each other. Whereas in developers prefer building microservices applications for such use cases to mitigate deployment risks, sorry. If a microservice fails, so the other microservices remain operational, which limits the impact on the application. So your overall application will not fail in consideration with microservices as your application. Later, it also accelerates the time to market. So software development effort for a monolithic application increases exponentially as the core complexity of your application grows. So eventually, developers have to spend more time to manage and cross-reference code files and libraries at the cost of building new features that come into the market. So when you develop with a rigid infrastructure, it creates delays to the anticipated timeline that you have to launch your application. Conversely, in case of microservices, organizations have expertise and can build and release digital products faster because your microservices are not dependent to each other. And as you have a distributed software architecture, each developer that is working on a specific microservice focuses on a small chunk of code instead of the whole application or the larger code that you have running in your application. So microservices also decrease your total cost of ownership. So both in microservices and monolithic applications, there is an incur of expense during the development phase, the deployment, and the maintenance that you have to do. However, the microservice approach is a very cost-effective one in a long-term situation. So you can scale microservice applications horizontally by adding compute resources on your demand, and you can also have to address resources for the individual service, not the entire application. So you add resources to your specific microservice or your specific process that is being running. So you don't have to add it throughout all the microservices. You add only in that specific one where you require it. And to scale monolithic systems, companies have to upgrade the memory and processing power for the application as a whole, which moves out to be more expensive rather than considering the expenses that we have to handle in a microservice application. So moving on, we have our next slide wherein we'll look into how, and I mean, we should look into when should a client or a company should think of modernizing their monolithic application to microservices. So the decision to use microservices over a monolithic architecture depends on several factors, especially it completely is dependent on the use case or the application that you are using. It completely is dependent on that. Um, there are some factors that should be considered if you are thinking of moving from your monolithic architecture to microservices. Let us look into some of the scenarios in which choosing a microservice might be more appropriate than a monolithic architecture. So firstly, let's consider the application size that you have. So the monolithic approach here is more suitable when you are designing or consider a simple application or a prototype, because monolithic applications use a single code base and a single framework. So developers can build the software without integrating multiple services, which will also reduce you with cost. And wherein microservice applications may require substantial time and design efforts, which doesn't justify the cost and benefit of your smaller projects. So if you have a single application or a single prototype to be run, you can consider monolithic application. You don't need to shift to microservices just to get into more complexity. Meanwhile, if you have a complex application that is to be run, microservice architecture is better in that use case. So it is better for building a very complex system. It provides a robust programming foundation for your team, and it supports their ability to add more features and flexibility. For example, you can consider Netflix. We can consider Netflix. It actually uses AWS Lambda service to scale its streaming infrastructure and save the development time that they have to put into if they had a monolithic one. Next, we have the resource efficiency. So microservices can be more resource efficient as you can allocate resources based on the needs of each service, preventing over provisioning for less resource intensive applications. So this, you can consider this if you have you want to allocate resources to particular services and not for your whole application, then this is the microservice option is a good one. Moving on, we should also look into the technology diversity that's coming up. When you need to use different technologies, frameworks, or programming languages for various parts of your application, microservices in this case provides the flexibility in it. So to select the most appropriate technology for each service that you have running, wherein in a monolithic architecture, you are typically very constrained to a single technology stack. As I said before, you have to, there's a complex complexity if you have updates and if you want to change technology of your application, you'll have to change all of the technology. Wherein in a microservice, you can change for your particular microservices, the technology of that. Next, the frequent updates and continuous deployment, if you have such factor that is in consideration in your application, microservices makes it easier in this case. So to implement continuous integration and continuous deployment practices, updates to individual services can be released independently without affecting the entire application. Moving on, we have, as you can see, this is a very basic architecture wherein you can see we have a computer application, the API calls that are run for different microservices which are connected to a database. So as you can see, this is a very distributed architecture. It is not completely dependent, and if any failure occurs considering first API call or something happens in the first one, the second, third, fourth will not be affected. Now let us look at some of the benefits of microservices that we can avail. So monolithic architecture adds risk for your application. availability, because many all of the whole application is actually dependent and it is tightly coupled processes. This increases the impact of a single process failure, wherein with a microservice architecture, an application is built as the independent components that run each application process as a service. So each of your application, the process of the application is run as a service, and they are not correlated completely to another application process that is being run simultaneously. And these services communicate via a very well-defined interface using lightweight APIs, as I said before. And these services are built for business capabilities, and each service performs a single function. So because they are independently run, each service can be updated, deployed, and scaled to meet the demand of for the specific functions of any application. So the benefits that we can have, firstly, we can have improved productivity. So breaking an application down into smaller autonomous fragments makes it easier to build and maintain. So each service over here can be developed, deployed, and managed independently, and can utilize different programming languages, different technologies, and different software environments based on the needs of each. The reduced code base of each modular element of an application makes releasing and scaling and deploying different services more manageable, and the associated tasks can be divided among development teams and can be worked simultaneously. We have better resilience when we work with microservices. So implementing a microservices based architecture adds ease to the process of identifying and resolving the root cause of performance issues. So the improved fault isolation offered by the individual modules means larger applications remain unaffected by a single failure. So over here, if you consider you have an issue occurred in a specific process and you want to get into the root cause of it, so you can easily identify that too, because you don't have a larger code or a larger service to look into, to dive into. You can just look into that specific service, dive into that service and look at the root cause, what caused that issue, and resolve it immediately without having any interdependencies. So consequently, the risk of the downtime is reduced, since the developers can roll back and update or make the changes to a module without redeploying the entire application. We can also have the increased scalability option advantage. The fact that each service can be written in a different language or technology. This allows the DevOps teams to choose the most appropriate tech stack for each module without concerns about the incompatibility. Sorry. So over here, you don't have to run your whole application on a single technology. You can have the different processes that are running beneath it with the different technologies, with different PHP versions. Whatever is compatible to that specific process, it can be run accordingly. So individual services can be, or can also be scaled independently, and new components can be added without requiring downtime and redeployment of the entire system. We also optimize the business functionality. I mean, the microservices also optimize the business's functionality. When the focus is on a specific service, for example, versus the entire application, it is easier to customize the needs of each component to improve the business's functionality. Working on individual modules allows the team to focus on the business capabilities instead of the technologies. So the existing services can be adapted for use in different contexts without recreating an entire module from scratch. Also, another very important factor, you can reuse the code that is being used in your microservice architecture. So dividing the software into small, well-defined modules enables teams to actually use the functions for multiple purposes. So there are certain functions that can be used in two services also, three services also. So you can reuse that code and you don't have to code the whole thing again and again every time. Service written for a certain function can be used as a building block for another feature, and this allows an application to bootstrap of itself, as the developers can create new capabilities without writing the code from scratch every time. So this reduces your time that you're spending also for that specific component. Moving on, let us look at a very basic process that you should be following while decoupling your monolithic architecture to a microservices one. So the process of decoupling this in the cloud basically involves several key steps. So let us look at some of the high level process key steps that should be considered. Firstly, you should have a good assessment and a complete planning done on your full monolithic application that's running. You should understand the existing monolithic application, including its architecture, the dependencies that it has, and the performance that is giving. Next, you should identify the microservices that you want to use, identify the functional boundaries within the monolithic application, and determine which components can be extracted and refactored into microservices. This will be completely dependent on the assessment that you have earlier. So you'll get to identify which service is not completely interdependent, and you can differentiate it and completely have a new process or a microservice defined for that. So define the responsibilities and data boundaries for each of the microservice that you identify. Next, you should have a technology stack selection. So choose an appropriate cloud specific services and technologies for each microservice. So in the market, there are several cloud service providers also, and multiple services that the cloud service providers provide you for, mainly for the microservice architecture. So look into that and choose appropriately according to your use case. Next, containerization and orchestration. Implement the containerization using tools like Docker to package the microservices for easy deployment and scaling that it gives you. And also utilize the orchestration tools that are in market like Kubernetes or cloud specific services. If we can consider, we have the Amazon ECS service that you can use. Next, the service discovery and load balancing. So set up a service discovery mechanism to allow microservices to locate and communicate with one another, and also implement load balancing to evenly distribute traffic across service instances. So this will help you have the load balanced apart all, I mean, distributed to all the microservices evenly. And also the API gateway. So you should implement an API gateway to manage the API traffic, the authentication and routing for the clients. This method will simplify the client interactions with your microservices. Also, continuous integration and deployment. Establish the CI/CD pipelines for having the automated testing, integrations, and deployment of your microservices done. Also, you should keep in mind the monitoring and logging of your microservices. So you should implement very strict monitoring and logging solutions to track the performance and the health of your microservices. And also, with these process coming in line, you should gradually roll out and increment the migration. So the transition, you should gradually have the transition to microservices by rolling out one service at a time. Slowly, you'll have all of your services, all of your the whole monolithic application distributed to a microservice architecture by gradually transitioning this, simultaneously running the steps that I defined before. So start with a very less critical services in your beginning stages to learn from the processes, and then make the adjustments and the scaling as per your need. Moving on, let us now look at the the services that specifically AWS Cloud provides us for having a microservice architecture. So typically, a monolithic app consists of different layers, naming there's a presentation layer, an application layer, and a data layer. But in microservice architecture, on the other hand, we have separate functionalities into a very cohesive verticals according to specific domains. So rather than technological layers like defined before, we have separate functionalities for each domains. And as you can see, the figure below illustrates a reference architecture for a very typical microservice application on AWS. So this is a very basic architecture. Uh, so let us now we look into each component very briefly. So firstly, we have the user interface. Modern web applications often use JavaScript frameworks nowadays to develop single page applications that communicate with the backend APIs. So these APIs are typically, as you all know, built using the REST or RESTful APIs or GraphQL APIs. So the static web content can be served using the Amazon Simple Storage Service, the S3 service, and Amazon CloudFront. So moving on to the compute implementation, the microservices that are used in here, APIs are considered the front door of microservices. And as they are the entry point for application logic, typically the RESTful web services API or the GraphQL APIs are used. So these APIs basically manage and process the client calls, handling the functions such as traffic management, request filtering, routing, and caching, authentication, and authorization processes. So AWS offers building blocks to develop the microservices, including Amazon ECS, Amazon EKS as the choices for container orchestration engines, and AWS Fargate and EC2 as hosting options. So there are multiple AWS services that you have for your microservices. As I just named them, Amazon ECS, Elastic Container Service, Amazon EKS, Elastic Kubernetes Service, for container orchestration engines like AWS Fargate and EC2, that is Elastic Cloud Computing, as hosting options. And AWS Lambda is another serverless way to build microservices on AWS. So you have to choose between these hosting options, depends on completely on your requirements to manage the underlying infrastructure that you have. And basically the AWS Lambda, it allows you to upload your code automatically, scaling and managing its execution with high availability. So this basically eliminates the need for infrastructure management. So you can move quickly and focus on your business logic. Lambda also supports multiple programming languages and can be triggered by other AWS services as or called directly from web or mobile applications. So if you want your architecture to be completely serverless, you can for serverless architectures. Um, AWS also offers several services to build, deploy, and manage containers. So the app2 container a command line tool for migrating and modernizing Java.NET web applications into container format. The AWS app2 container analyzes an inventory of the applications running in bare metal, virtual machines, Amazon EC2 instances, or in the cloud. extends the cloud service into on-premise environments for low latency local data processing, high data transfer costs, or data residency requirements. You can use this service with all the existing plugins. You can use all the existing plugins and the tooling from the Kubernetes community with the EKS service. So it is compatible with all the plugins that you have, and there's no compatibility issue faced for this service. Next, the Amazon Container Service. It is a fully managed container orchestration service. So this simplifies your deployment, management, and scaling of the containerized applications. Customers choose ECS for simplicity and the deep integration that it serves with the other AWS services. Next, the AWS Fargate service. This is also a centralized compute engine. It works with both Amazon ECS and Amazon EKS. Amazon work with Amazon EKS to automatically manage compute resources for container applications. And the next we have the Amazon ECR. So it is a fully managed container registry, Elastic Container Registry. So it offers the high performance hosting, so you can reliably deploy applications and artifacts anywhere. So the next component, that is data store. The data store is used to persist the data that is needed by the microservices. So the popular stores for session data are in memory caches such as Memcached or the Redis clusters that we have in Amazon AWS. So AWS basically offers both technologies as part of the managed Amazon Elastic Cache service. So this service basically offers you Memcache clusters also and Redis clusters also. So putting a cache between the application servers and a database mechanism for reducing the read load on the database which in turn may allow the
Rutuja, we are not able to hear you.
to be to support more. So can also improve the latency to more writes. Cache can also you face any latency in the application. This that will also be improved. The next we have databases offered by AWS. Is also that is also AWS. We have relational database also that is store the structure. and the business objects. And we have the AWS. AWS offers us 6 database engines: Power, Oracle, MySQL, data that is Microsoft SQL Server, MariaDB, Postgres SQL, and Amazon Aurora. Managed services, we are completely managed services, and relational databases, however, are not for any database designed at scale, which can make it difficult and time intensive to apply techniques to support a high number of queries if you face any that is offered. This have scalability option that we were facing in relational databases. This will be the NoSQL database. So it favors the scalability, the performance, and availability over the consistency of the relational databases. And one important element of NoSQL database is that they typically don't enforce a strict schema. So the data is distributed, can be like scaled horizontally and is retrieved in keys. So because one thing well, they are well suited to NoSQL process and NoSQL data is there. There is a right use case that you have and the requirement that easily from we have the configure or this will let you comments hello. So deployment and implementing and solving everything, human errors, impact that can be inconsistent time cycles also. Robust monitoring, maintaining the services like your services, to collect the metrics, all the changes, the updates, and everything that is being made in your services in the metrics and the logs that are configured. This data actually can help you identify and resolve the issues if you face anything, and optimize the resource usage and improve the overall performance of your microservices. So you can also look into the metrics of each service, the how much is it is utilized, what is causing it for not giving you better performance. All of this can be monitored using these services. You should also secure your microservices. Very important, you should have security in place in all of the architectures, and security should be a very top priority when building the microservices on AWS. So you should use AWS Identity and Access Management, that is IAM service, to control the access to your microservices and AWS resources. Also, you should implement encryption both in transit and at rest to protect your data, so that the data that is in transit and in rest in between your microservices should also be encrypted. For this, you can use the KMS key management service also. Finally, use the tools like AWS WAF and AWS Shield to protect your microservices from any security threats. Next, to plan any failure. So you should have a very good plan if you face any failure. Design your microservices for resiliency by planning for the failure. Implement strategies like circuit breaks, retries, and fallbacks to handle failures gracefully and independently. Additionally, use the AWS services like autoscaling and Amazon Route 53 to ensure high availability and fault tolerance for your microservices. Also, lastly, but this is very important part, that you should make an informed choice between the serverless containers and full Kubernetes. So when choosing your runtime platform, consider the following services. If you want AWS Lambda, this is a very best solution for lightweight microservices with the unpredictable demand or quick stateless tasks, allowing developers to focus on their code without concerning themselves with the underlying infrastructure. So if you have a lightweight microservices and you have high demand tasks to be done, you can go with AWS Lambda. Or you have quick to run, deploy, and scale. And a new thread was created whenever a new job is needed to complete, and each job took up like different amounts of memory and CPU. So this continually created inefficiencies, and lack of resource isolation allowed memory limit errors, so to bring like down the entire application. The infrastructure engineering team attempted to move to a microservice architecture using the Docker containers, but they ran into problems as they tried to use Apache Mesos to manage the cluster and containers. So Coursera didn't have the expertise or time required to manage a Mesos cluster or all of these issues that they were facing. So they came to AWS. So AWS, why did they choose AWS? So as we all saw in the previous slides, there are multiple customized services that AWS offers for your use case. So over here, the Docker containers on Amazon EC2 container service enabled Coursera to easily move to a microservices based architecture. And each job is created as a container, and Amazon ECS schedules the container across the Amazon EC2 instance cluster. So Amazon ECS handles all the cluster management and container orchestration, and containers provide the necessary resource isolation. So over here, they are using ECS container, I mean EC2 is container service. So they have it completely customized according to their use case. Wherein before, when they tried it by themselves, they, due to less expertise, they couldn't meet the required solution. So the benefits that they got by implementing Amazon services is that they have ease of use, because Amazon ECS setup is very straightforward and it manages all the details of the cluster. The team had a prototype up and running in under like 2 months. So this was very ease of use that they got. Speed and agility, time to deploy software changes went from hours to minutes. So each team can now, like, they got to develop and update its respective applications independently, because the applications are resource isolated with no cross dependencies. So they got a very speedy solution also with more agility in it. Also the scalable capacity, auto scaling groups that allow the compute capacity to scale up to handle dynamic job loads were also configured. So like that also gave them the scalability feature. Also the operational efficiency that they got in their application. There was no extra infrastructure engineering time spent installing software and maintaining a cluster, as Amazon ECS handles everything from the cluster management to container orchestration. So these were the benefits that they got by implementing AWS services for the use case of having their monolithic application converted to microservices. So here we come to an end to our session. I hope you all have understood and got a very brief idea of how you can decouple your monolithic application to a microservice architecture. Thank you so much. Over to you, Suvarna ma'am.
Okay, thanks, Rutuja. Thank you for such an insightful presentation, and thank you all for attending the session. We appreciate your being with us today. And we would like to get your feedback on the session to improve the experience. I have pasted one link in the chat box, so I request you to share your feedback through the link shared in the chat box. Have a great day ahead. Thank you.